Hello everybody, this is Karma Killed the Cat, and welcome to your 12th, I think, C++ tutorial. In this tutorial, we'll be going over overriding functions and classes from the parent class to the child class. But before we get into that, I'd just like to say sorry for not posting any videos in 2 or 3 weeks. School and personal matters got in the way, but I should have more time now, so we should be able to get back to regular videos. So now let's get on to the tutorial. So if you remember from last tutorial, we created a parent class called enemy and a child class called special enemy, and we used inheritance to take all the functions and variables and other data from the enemy class and put it into the special enemy class, and then we demonstrated that in the main function. So in this tutorial, I'm going to show you how you can override functions from a parent class in the child class. So you see here we have the attack function in enemy, so we have attack, and then we have the special attack function in special enemy. So if we go to the CPP files, we can see that the functions are very similar. They both just output a line. One says the enemy did, and then it takes the damage variable, and then just says damage, and the other one does pretty much the exact same thing. So it may seem pretty redundant to make a whole separate function in the special enemy class, just to do pretty much the exact same thing, and if you thought that, you are correct. But without overloading the function, which we can't do without putting a separate parameter in the function, we can't just override the function in the special enemy class. So what we have to do is we have to put a modifier in front of the function called virtual. And this just marks the function to be overrode in the child class. So now to override the attack function from enemy that we've just made virtual, to override it in the special enemy class, we just delete this, or we don't need to delete void. We just change this to attack. So we have the same function name as we have in enemy. We just get rid of the virtual. And then in the CPP file, you see that creates an error. Just get rid of this. And that fixes all the errors, except probably in main. So let's just get rid of this. And actually, we'll change it to e2.attack. Whoops. Okay, so now it should build. So now we see we have the attack function in enemy says the enemy did damage, damage. And in the special enemy, it says the special enemy did the damage value and then damage. So if we run this, the enemy did 20 damage, the special enemy did 40 damage, and then the other two functions that we don't care about anymore. So we have overridden the attack function from enemy and changed it to something slightly different in the special enemy class. But it could be completely different. You could put whatever you want here in this function. It doesn't have to be related at all. It probably should. It doesn't have to be related at all to the enemy's attack function. But now, from special enemy, there's no way to access the enemy's attack function. So if you want to do that, actually, I shouldn't have said that there's no way to do it, just we don't know how yet. So if you want to access the enemy's attack function, you just say enemy, then colon colon attack, and semicolon. So now if we build this and run it again, the enemy did 20 damage, the special enemy did 40 damage, and the enemy did 40 damage. So you can see that it ran the enemy's attack function because it doesn't say the special enemy did 40 damage, but it took the damage value from the special enemy class and used that in the run of this function. So that is how you call the parent class's version of a function that's been overridden in a child class. So now we just need to go over one more thing before I just talk to you a little bit about performance issues involved with virtual functions. And that last thing is abstract classes. So that probably sounds a bit more complicated than it actually is, but it's actually pretty simple. So an abstract class is any class that has what's called a pure virtual function. And a pure virtual function is just a function that is only allowed to be overridden. It can't have its own definition, and it can't be called from that parent class. It must be called from an override in a child class. So to make a virtual function pure, we just put equals 0 next to it before the semicolon. So now, if we build this, we'll get a bunch of errors. So it says, enemy cannot instantiate, I think that's what it says, abstract class, and that's in our main function. So we get rid of this, and that'll obviously create errors here. So we have to get rid of this, and it'll create an error here, so we get rid of this. And we also have to get rid of our definition of attack in the enemy class. And so we obviously need to get rid of the call to the enemy's definition of the attack function in the special enemy class. So now if we build this, it should work. And it'll work almost the same way it did before, just without any of the output involving the enemy. So the special enemy did 40 damage, and the other function we still don't care about. So by making a class abstract, you're really just turning it into a template that just to get data in child classes from. So we got the original declaration of the attack function from enemy. We got the original we got the damage variable and health variable, I think, from enemy. So by doing this, making a class abstract and making a virtual function pure, you're kind of taking away the main use, in my opinion, for virtual functions that we'll get to, I think, after our pointers tutorial, which will either be the next one or the one after that. But it still can be useful. It's just marking that this class is a template and is never meant to be used. So let's talk about some of the performance issues that could be involved with virtual functions. So say we have a parent class and a child class, and that parent class has a virtual function in it. Not a pure virtual function, just a normal virtual function. And in that child class, we never override it. So then we make an instance of that child class and call that virtual function from the child class, which you're allowed to do even if you don't override it, as long as you don't make that function a pure virtual function. So now what the program has to do is it has to look through the child class, see that that function that's virtual hasn't been overrode at all, and then it has to go into the enemy class and it has to run the function from there. And that takes a lot more effort from the program to do, and if you have a really big program with a lot of virtual functions being called, it adds up and slows the program down. So minimize your use of virtual functions. But that's all for this tutorial, so see you in the next tutorial.